you want to go to list and then enter the data set into L1. I'll show you how to do that here if I just can get my calculator. All right, let me share that screen. Okay, so it's under second stat, that's your list. I'm sorry, that's not correct. That's how you get the list. You go to stat edit. Stat edit gets you the list. And then you enter the data in there. 5, 5, 8, 8, 9, 9, 9, 10, and 14. Most errors are the result of just not putting the data set in correctly. So I'll write some of this down. Stat edit, like that. Let me know when you get up to this point. And then I'll show you how to actually calculate the 5-number summary.
Okay. Okay.
All right, so you quit out of that, second quit. And then you go back to stat, and then calc, stat calc, one variable stats. And then yours may have a screen where it says to like choose the list. I have to manually enter the list, but yours should default to L1.
Yeah.
And then you just hit enter and it spits out all this stuff. Now, the mean it gives you, that's the top one. The sigma X is your standard deviation. And then if you hit the down arrow, it'll give you what we wanted here. Min Q1, median Q3, and max of 14. So actually, I must have misspoke on some of the calculations I gave you. I would just go with whatever this gives you for that. So that's your 5-number summary, the 3, 5, 8.59, and 14. Hopefully yours is the same. Okay. Is that all right?
Yes.
Okay, let me go back to the other screen. So I misspoke here. You actually don't take the median of the, it's actually the 5 numbers. Now this is getting really bad, but it's actually the bottom 5 numbers and then the top 5 numbers for that. So this ends up being 9. I would just use the calculator just to keep that simple.
Okay.
Okay, big part of this course is interpret. I guess I'll also add here that almost every student takes a statistics course in college, so you will see this again. So the interpret means to write a sentence, and you want to frame it in terms of like what they're doing. So it says a student studying the sleeping habits of seniors at his high school asked how much sleep they actually get on Saturday night. So the standard deviation is a measure of spread. Measure of spread around the mean. So you can use words like varies, but you want to say that you want to create a sentence that says something like the spread of hours around the mean sleeping is 2.93, or it varies from the mean about 2.93. You may also want to say like whether it's a lot or a little. And I'm not sure how you would know. I mean, because I don't know, the numbers don't seem right either. I mean, who gets 3 hours of sleep on a Saturday night? I mean, you eventually get more sleep at some point, but the instructor's just looking for a sentence there, something that conveys that you know what that means.
Okay.
All right, so for the it says the graph this data as a dot plot, histogram, or box and whisker, and label each axis. Like it almost is like they're saying like do all of them, but which one do you want us to do? I mean, we could do all of them if you wanted, if you were unclear about how many how to do
Yeah,
each.
could we do all four? Or all
Yes,
three?
yes. Okay, so the dot plot we'll do for this one. So for the dot plot, you go back to your data set. And so the first number in your data set is 3. So you put a dot there at 3. So this corresponds to 1. And then for 5, there are 2 5s. So you have 2 dots there. Sometimes they're closer together. I'm not choosing to do that. There's 2 8s. There's 3 9s. And then there's 1 10 and 1 14. So that's a dot plot. It's literally just dots going vertical.
Okay.
Okay, so let's do it for a histogram now. Histogram is really similar. So you count the number of numbers you have. So 3 in this case, you have 1 3. So it's got a height of 1 at 3. And then for 5, there are 2 5s. So you do the same thing there. There's 2 5s. There are 3 8s. And there are 3 9s. 1 10. And 1 14. Oh, and you need to label each axis, which I'm terrible at. So the left side here is frequency in all of them so far. And then this is hours of sleep on a Saturday night. And the same thing for the previous one. You would want to have the same labels for that. So there's really no difference between them in terms of like what they look like. I think the rectangles are a little bit more familiar to you. Like we looked at some SAT, ACT stuff like this. So just that you could be asked for either. The box and whisker is the more, I guess the more common one in this class that you see. So you start with the median. So the first thing you want to determine is the median. And we found that the median is 8.5. I don't remember. Yeah, 8.5. So you go to 8.5 and you draw a vertical bar there at 8.5. You can label it if you want. Then you go to Q1. So Q1 is at 5 and you draw another vertical bar. That's Q1. And then Q3 is 9 right there. And then you draw rectangles.
Okay.
And this is kind of this is where we need to like, well, I guess we'll do that next. So then, and this works most of the time. I'm just going to go with it for this. We got a lot to cover. The next thing is you draw the min. The min is over here at 3. This is the whiskers. Now you stop drawing vertical lines. That's the whisker part. I don't know if you've got a cat or not. I don't remember do dogs have whiskers? I don't think they do.
Kind of, not really.
Yeah, I know cats do.
Yeah.
And then you go to your max. Like that. So that's the whisker.
Okay.
So there's a couple of things here too that you might see. So this is considered the middle 50% from Q1 to Q3. And then from Q3 to Q4, or sorry, the max, Q3 to the max, that's the upper 25%. And then the min to Q1 is considered the lower 25%. So what they sometimes do on tests and quizzes is they give you the graph and then they ask you questions like, what 2 numbers represent the lower 25%? And you have to be able to say, oh, it's the min to Q1, it's 3 to 5. Or which numbers are representing the middle 50%? Oh, that's 5 to 9. Or they might just straight up ask you, what's the median? It's right there in the middle. Or what's the max? Max is 14. Make sure to circle your choice. Okay. Do your teachers ever talk about a flipped classroom?
I don't think so.
Okay. This is like a flipped classroom question. All right, choose one of the following 3 questions to answer. Did you choose one, or is this just going back to figure it out?
I haven't chosen one.
Okay. All right, let's look at them one at a time. Let me not do it this way. Okay, it says the first one says if all the hours in the first 2 quartiles of data were changed to 4 hours, how would the value of the mean and the median changed? So the first 2 quartiles in your histogram is everything from the min up to the median. So this is the first quartile, the second quartile, the third quartile, and the fourth quartile, like that. So what they're saying in this problem is everything that's less than the median. So now we're going to go back to our data set. Sorry, let me go grab the data set. All right, so here's your data set. It says everything less than the median, which is everything less than 8, was changed to 4 hours. So your data set of 4, 4, 4, 4, 4, 9, 9, 9, 10, 14. And they're asking, how would the value of the mean and median change? So this is actually kind of like an SAT question. It's like, which data set has the lower mean, A or B? And the idea is like you're looking at the lower half. So what do you think these values do that are much smaller than all the ones in A except for that first one?
The one in B is going to be smaller.
That's right. So you're going to say the mean is smaller. Now, I know you probably want to calculate it because I would too as a student, but you have sufficient evidence to say that it's smaller. You don't have to actually do it. And that's the point of these questions, is to say, don't do it. Just tell me what it is. I mean, that's the SAT question. Now, how about the median? How about the median? Did it also change? This one's a little tougher to answer.
Yes, because it falls between number
Yeah.
4 and 9.
Yeah. Now, I don't think that was the intent of this question, because a lot of times they want you to like chop off a lower value and see that the median did not change, but it did get smaller just for the exact reason you just said. But they often ask that question, like if you remove the largest value or the smallest value, what happens to it?
Mhm.
All right. Any questions on that before we move on to 2?
No.
Okay. All right. So let me grab the data set again. All right. Suppose 4 more values were added to the data, each exactly equal to the mean. So that means we're adding in 8.5, 8.5, 8.5, and 8.5. Okay. So the first question says, how would this affect the mean? How is the mean affected? And sometimes sometimes it's better to go back to a much simpler example. Like let's say you just had 3 numbers, like 1, 2, and 3, and you added a bunch of 2s to your list.
Mhm.
Does that change the mean?
Yes.
Okay, let's just add 1, 2, and I want you to calculate the new mean of those. So the original mean here would be like 1 plus 2 plus 3 divided by 3, which is 2. And then the next one is 1 plus 2 plus 2 plus 3 divided by 4.
Oh, it's the same?
It's the same, yeah. So when you add numbers on top of the mean, it does not, the mean is not affected.
Okay.
So that's kind of like a Quizlet type of question. Is not affected. Now the
Okay.
standard deviation is talking about spread. And we looked at some data sets on the SAT HC stuff that really helped to emphasize this point.
Mhm.
A dot plot would really help. So let's say you had this dot plot here, and this is at 2, 1, 2, 3. And then let's say we had another dot plot. Sorry, that's not a point right there. Which has more spread?
The one on the left.
That's right. So the standard deviation on the left is larger, and the standard deviation on the right is smaller.
Mm-hmm.
Because more of the data is centered around the mean.
Yeah.
So what I would recommend is if it's not clear with the data set they're giving you, to choose a much more simple data set and then do the exact same thing that they're asking you to do to
Mm-hmm.
answer it. Last question here. Really, these are kind of interesting questions because these are real things that do happen. Like we did recently have daylight savings time, and the question is, okay, let's say you turn back the clocks so that every student had one more hour of sleep that they wanted. What's going to happen to the mean and the standard deviation? So our new data set is 4, 6, 6, 9, 9, 10, 10, 10, 11, and 15. And when you calculate the original mean was 8, I believe. So the new mean you will find is 9. If you want to calculate that. So the idea is if you add 1, you add 1 to your mean.
Okay.
But the question though is, well, now the next question is, well, did the standard deviation get affected? All right, so let me go grab a dot plot we did earlier and see if I can actually snip this. Okay, there it is. Because I think this is a really important point here for you to see, because there's certain things that affect one but not the other. It's rare when they're both affected. So here's the original dot plot. And then I'm going to grab and this is the new dot plot, except that's at 4 and that's at 5 and 6 and 7 and 8 and 9 and 10, 11, so on here. 15 hours of
Mm-hmm.
sleep. Oh, that's a lot. Okay, so is the shape of the data the same?
Yeah.
Yes. So when the shape of the data is the same, that means they have the same standard deviation. So there is no change in this case. Again, sometimes a simpler example is easier. Like if you had 3 dots around 1, 2, and 3, and then you had 4, 5, and 6, these both have the same shape. So the standard deviation is the same.
Okay.
All right, so we really spent a lot of time on that. The next questions should go better. Let's look at this nitrates problem, because I think it's the most similar to what we've been doing.
Okay.
This one right here. All right, so they're giving you 2 dot plots. These are both dot plots here. And one of them, I think you can see, has more spread. The Millbrook has more spread.
Mhm.
That's confirmed by the standard deviation. The standard deviation of Millbrook is a little bit higher than Stony Brook. All right. So that's like one thing to notice. You could look at the means. The mean is one's lower than the other, and so on. This 5-number summary over here, though, this is going to be really important. This is our 5-number summary for both. Now it says to determine if there are any outliers. So I avoided talking about this in the first couple of questions. The way you determine outliers is you have to first calculate what's called the interquartile range, IQR. And that's always Q3 minus Q1. So we need to do it for both, but I'm just going to tell you that the only chance of outliers is going to be for Millbrook. So Q3 for Millbrook is 10.5 minus 4.5 for Q1, which is 6. So to determine any outliers, you have to determine what's called an upper fence and a lower fence. So the upper fence is Q3 plus 1.5 times the interquartile range. So for your problem, that's 10.5 plus 1.5 times 6, which ends up being 19.5. The lower fence is Q1 minus 1.5 times IQR. So it's Q1 is 4.5 minus 1.5 times 6. So you end up getting a negative 4.5. So here's how you determine if there's an outlier. If there is a number above the IQR, and then the next one is below the IQR. So there is a number above the IQR, and that is this 20.
Okay.
So whenever they ask you if there's an outlier, like there usually is, unless you're like doing a worksheet where but if it's on a test or quiz, it's like, hey, there's probably one.
Okay.
Box plots. Okay. B here. Appreciate you sending good pictures of these. It's like sometimes I get these at an angle. It's hard to rotate the plots here. Okay, so we want to do the box plot of each. So we're going to refer back to that 5-number summary. So we're going to start with Stony Brook. Hopefully you're looking at it. You want to start with the median of Stony Brook, which is 5. So I'm going to come up here for Stony Brook. That's 5. That's its median. Then we go Q1, which is 3.5, right about there-ish. Q3 is 7.5, I don't know, right about there. And then we connect them here. And then the min and the max are next. There's a min at 0 and a max at 12. And those are your whiskers. Oh, I guess sometimes they put little things on the end. Just go off what your instructor does. If it's not really all that important. Okay, so Millbrook is slightly different, and it's because there's an outlier. But the first parts are the same. You still go, okay, here's the median there, about 8.25. Q1 at 4.5-ish, right in there. Q3 10.5, so maybe right there. Draw a rectangle like that. The min is fine. The min is at 0. So when there's an outlier, though, and there is for the second one, you stop at the upper fence. So we calculate that upper fence of 19.5 being right about there. That's not very accurate. Sorry. Let's move it over a little bit. So there was right out there. So you still draw the whisker, but you add that extra point. Sometimes they're starred for being outliers like that. But the line, the whisker doesn't go all the way to it.
Okay.
Do you feel like you could do this on your own based on what we've done tonight?
I think so.
Okay, because I'm almost certain you're going to get asked to do a box and whisker plot on these.
Okay.
So let me just talk about the next when it says the center. If you look down at part C, it says the center. So the median, what can you say about the median of, I guess this is Millbrook and Stony Brook. What can you say about the median of Mill compared to Stony?
The median is higher in the second one.
That's right. So that's like it in part C, it's asking you to write a few sentences. You would want to say that the median is higher for Mill. So I think the next one that's probably easier to talk about is the spread. Looking at these two drawings, which one is more spread out?
Mill.
Mill. So you would say something like the Mill is more spread out. So for shape, they're usually talking about two things. They're usually talking about negative skew or positive skew. All right, so negative skew looks like this. And positive, sorry, I got those backwards. Negative skew looks like this. And sometimes it's symmetric, is obviously the one that's a little bit more even left and right. So in terms of how to do that here, let me go back to this. I'll use a different color. So for the first one, the idea is that there's kind of a steep run up here. I don't know if that, no,
Mhm.
that's not very good. Sorry, that's terrible. The second one's easier to draw. The second one's a little bit more more uniform, symmetric.
Mhm.
The first one is a little bit like higher and then it falls off. So I'm trying to say is the first one is negatively skewed, not doing a very good job, and the second one is symmetric. And really it comes from like the weights inside the boxes. So for the first one, see how there's more of the weight kind of over here to the left.
Yeah.
That's why it's negatively skewed. It's more to do with this right here. And the second one's more even. Although I don't think these are great examples, but that's what they're looking for with shape generally. All right, is it okay if I move on to Unit 5, normal distribution and Table A questions?
Yes.
Okay, here we go. On a recent math test, the mean score was 75 and the standard deviation is 5. Mike scored a 93. What is the 25th percentile for the math scores? Okay, so the idea here is that in a normal distribution, here's the mean 75. The 25th percentile means that there is 0.25 area in the curve right here. Now, are you more comfortable using a table or your calculator to do this? Or neither at this point?
I don't know.
Okay. Let me show you the table method, I guess, first. Do you have a table you've been using for these, table A?
I think so. Let me get this sheet out.
You're always welcome to send over the tables so that I can help help you, because they're not different, but they're just, it's always nice to use the one you're using
Yeah.
rather than whatnot. So let me, because there's kind of also a way to do this directly. Let me grab snip in this table. All right, so I've got this table snipped in. So you probably have a table A that looks something like this.
Yeah.
Okay, so the idea is that the Z scores are on the left. The Z scores are here. And the areas are in here.
Mhm.
So it's really important as a student is to decide, well, am I given an area or a Z score? And this time I'm giving you an area. So what you're looking for 0.25 in the table, not the column. So it's kind of right there between those two, or right kind of, I guess it's the one on the right.
Mhm.
Is that even correct? Sorry, it doesn't look right to me. Point is 0.6. Sorry, I just a little bit tired tonight. Let me get this is the wrong thing. So see how 0.25 is between those two values.
Mhm.
So that's between minus 0.67 and minus 0.68. And if it's not clear how I got that, that's the minus 0.6 and then the 0.7 and the 0.8.
Mhm.
Have you seen this, been doing this?
Yeah.
All right, so that's really important. Okay, so it doesn't matter which one you pick. You just pick either one here. So in terms of how you do this problem, the Z score is calculated as X bar, or your X minus mu over the standard deviation. Have you seen that before?
Yes.
So what did we just find from the table? We found the Z value, minus 0.67 equals X minus the mean score was 75 and the standard deviation was 5. So I'm just substituting those numbers in to this formula. And then from here, you're just solving for X. So let me talk through that. So you multiply both sides by 5. It's 5 times minus 0.67 equals X minus 75. And then you add 75 to both sides. So it's 75 plus 5 times minus 0.67. And that is your test score. That's the 25th percentile.
Okay.
So that ends up being 71.65. So sometimes it's unclear, like what does a percentile even mean? I like the best explanation I ever got is, let's say there are 100 people standing in line.
Mhm.
If you're in the 25th percentile, that means there's about 25 people below you and 75 people above you.
Okay.
And that may be good, may be bad. It depends on the application. But that's what's going on here. Now, probably more interesting to know how to do this on the calculator. So let me go back to that and see if you like this. I don't know if this has been covered in your class, so if it hasn't, this won't be very helpful. Let me just check here. Yeah, okay. So I did a second distribution. Have you used inverse norm before?
Yes.
Oh, good. Now your calculator is probably gonna be much more helpful than mine. Mine doesn't actually give me anything when I hit enter. Can you tell me what your what the screen shows or tells me, or just tell me what's on the screen when you pull up your calculator.
How did you get inverse norm again?
Okay, go to second distribution. And then you go down to number 3.
Okay.
I can look it up. It's just, I gotta search.
This is area.
Okay, so the area is the area in the left tail. So that's the 0.25. What's the next one that what's the next option that it gives you?
It gives the mean, which is
Okay.
0.
So your mean and your problem is 75. And then the next one is probably standard deviation.
Mm-hmm.
Okay. And is there anything else?
It says tail, and then there's an option to click left, center, and right.
Okay, so left tail is I believe 1,
Okay.
and that didn't work. Maybe it's not 1. Maybe it's 0. So choose left tail. So I obviously don't have the right options in here. Sorry,
I got negative 0.67.
so that's not good. Oh, so you used 0 and 1, didn't you?
Yes.
Okay, so that's how you get the minus 0.67. You want to, though, use the mean of 75 and the standard deviation of 5.
Okay. So
And that should give you the 71.65 that we just talked about.
$71.62.
Yeah.
Okay.
So you're gonna have better success doing it that way probably than looking it up in the table.
Okay.
And I'll talk you through how to do that now for these upcoming problems. But let me get back to that other screen. Let's look at another question here. If I could get to the right screen. Okay. What is the 75th percentile? So this is really similar to what we just did, except you're going to change one number. So this time we want 75% of the area over here. So in your problem, you're going to do an inverse norm, 0.75. Your mean is 75. Your standard deviation is 5, and it's still left tail. However you select that on yours. So why don't you give that a try? I'm going to do it using a different calculator that I like, and we'll compare numbers here.
Okay.
So did you get 78.37?
Yes, I did.
Awesome. All right, let's jump down to 2A because it's really related to what we just did. That way we have some consistency here, or not continuity, sorry, continuity of this. Okay, do you know what a floppy disk is? Just curious.
Yeah, I've heard of it.
You've heard of it? All right, the floppy disk company, these aren't even made anymore. I mean, unless they're gag gifts or something, makes a 3.5-inch floppy disk for all disk drives. Okay, all right, blah, blah, blah. All right, it's normally distributed with a standard deviation of 0.1 inches. That's sigma. And then this is the mean right here. Okay. This N is important. This is N right here. So the 30% of the discs widths were less than how many inches? So in this problem right here, they want 0.3 in the area. That's what they're saying. They're saying 0.3 right here. That's 30%. All right. Now you're gonna use inverse norm again. 0.3. Your mean is 3.5. Your standard deviation though is not 0.1. It's 0.1 divided by the square root of 1,000. So I think you've seen this in your class. It's divided by the square root of n. Have you seen that in class?
Not really.
Okay, let's say that is not the case yet for you guys. So let's go 0.1 and then left tail again. All right, so we give that a try for us.
Um, 3.44.
5, because the 7 would round. Now you should always ask your instructor what to round to, and the answer is whatever they want. It doesn't matter to me. You have to know that as well. Okay, now here's a related question, letter B. And it really comes down to being able to draw this normal curve. It's just an interpret. So you're interpreting this language. 45% of the disc widths were wider, really larger than how many inches? So this time, the right tail is 0.45. When you read this language, 45% of the disc widths were larger than how many inches? Do you agree? Do you see how it's now the right tail?
No, I don't understand.
Okay, let's say, so we have to interpret larger as greater than, smaller as less than.
Okay.
And we just have to go with that. We're really short on time here. We can obviously spend more time next hour if you want, but there's 3 types of questions you're going to see. One is left tail, like we have here. The other is right tail, and you're just interpreting this language. If it's larger than a certain number, then it's right tail. If it's less than a certain number, it's left tail.
Okay.
Okay. Now, in terms of how you do the calculation, you can still use the 0.45. Your mean is 3.5, your standard deviation is 0.1, but this time you need to indicate that it's right tail. I'm not sure what you would see on your calculator for that, but if you could give that a try, let me know what you come up with.
$3.51.
Yes. Okay, so we're going to stop here. I would recommend we continue going through this, but if you do not want to do that, that's fine with me. We can just move on to other stuff. But I'll see you in about 10 minutes and just let me know what you want to do.
Okay, perfect. Thank you.
Okay, see you. Bye.